All right, let's apply Kirchhoff's laws to this circuit to solve for the current flowing through each of the resistors. The first step is to assign the direction of current. Let's call the current passing through the 2 ohm resistor I2. Let's choose its direction to be from left to right. Current flowing through the 3 ohm resistor, let's call it I3. Let's choose its direction to be as follows. We recognize that the total current flowing into this junction must be equal to the total current flowing out of this junction. So let's choose the current flowing through the 4 ohm resistor as I2 plus I3. The next step is to recognize that current flows from higher potential to lower potential through the resistors. So we assign our plus and minus signs accordingly. And we also recognize that for our batteries, positive terminal is at a higher potential compared to our negative terminal. Now we're ready to consider our loops. Let's choose this as our first loop. Let's call it loop 1. Travel around this loop, right? We know that when we encounter a minus to plus, that's an increase in potential. Plus to minus, that's a decrease in potential. Plus to minus, a decrease in potential again, minus 3 times I3. Total change in potential equals to 0. Simplify 12, 4I2 minus 7I3, 0. Rearrange 4I2 plus 7I3 equals to 12. This is our first equation. Now we consider a second loop. Here, let's call it loop 2. Travel around the loop. When we encounter a minus to plus, that's an increase in potential. 4 I2 plus I3. Plus to minus, it's a decrease in potential, minus 5. Minus to plus, it's an increase in potential, plus 2 I2 goes to 0. Total change in potential as we travel around the loop equals to 0. So we can simplify this expression. 6I2 plus 4I3, bring the 5 over, goes to 5. We have our second equation over here. Now we have two unknowns, I2 and I3. We have two equations. We can solve them simultaneously. I won't go through the details here. Check that your answer for I2 is minus 0.5 amperes. The answer for I3 is 2 amperes. Now we're not concerned about the minus sign here because remember our initial choice of direction for I2 was arbitrary. When we end up with a minus sign, what it suggests is that the direction of our current for I2 was not as what we had originally chosen, but instead direction will be flowing from right to left. In the case of I3, we have a positive 2 amperes, so our initial choice of direction is correct. That's the direction of current for I3 is correct. Now, how about the current flowing through the resistor I4? Let's call it I4. We identified it earlier as the sum of I2 plus I3. So I2 plus I3 will give us 1.5 amperes. This is a positive value, so our initial choice of direction is